Hi everyone, here's a video on compound interest. So we've talked so far about simple interest, I equals PRT, and that's when we have interest increasing at a constant rate. So you put some money in the bank, you get paid some interest on that, but then if you get paid your second lot of interest, that would be paid on the original amount. It wouldn't take into account the fact that you've already got interest. When we've got FV, that's talking about the future value, that's talking about using compound interest. Future value is the amount of money that you get at the end of your period that you've had it in the bank. Compound interest is a little bit different from simple interest because say you put the money in the bank and then you get the first lot of interest. The next time you calculate interest, it would be based on the amount you put in plus the first lot of interest, and then the next time you get interest, it would be calculated based on the amount you put in plus those two lots of interest. So it's going to grow exponentially every time. So that's why we have this formula, which is an exponential relationship as we've got a number raised to a power over here. The variable is the power. So we've got FV, which is the future value. It's the time, the total amount that you eventually get. PV is the present value. Then we've got I, which is actually the interest rate, and that's calculated by doing the rate divided by n. So that's the rate divided by the number of times that you compound in a year. And then we've got n, which is finally the number of compounding periods. So lots of different values there, but we're going to talk about what they all stand for. So we've got the future value formula, but we can also calculate the present value, which is the value at the start, by doing the future value divided by 1 plus I to the power of n. And we can also calculate the interest rate. So the interest rate is equal, not the interest rate, that's equal to future value take the present value. So I'm just going to get rid of the rate bit. It should just be finding the interest. You do the future value, take the principal value. Now we talked about before how you have the number of compounding periods and you can compound monthly, annually, etc. If you're compounding annually, that means you're compounding once a year, and so n would equal 1. If you're compounding semi-annually, you're compounding twice a year, so n equals 2. Compounding quarterly, compounding 4 times a year, so n equals 4. Compounding monthly, n equals 12. And compounding daily, n equals 365. So again, copy those formulas and information off that slide. Using that so here we've got an example where we've got $20,000 deposited into an account for 3.5 years with compound interest paid monthly at 9% per annum. Find the total interest earned. Now if you remember, the total interest is going to equal the future value, take the principal value. So we first need to find the future value. So we'll write the formula. FV is going to equal PV times 1 plus I. You might want to write it as a little I raised to the power of n. So if we think about that, we've got PV is equal to 20,000. So you might want to just write on the side what each thing equals. So PV equals 20,000. And then we've got I, which is going to equal the rate, but rate is a decimal, so that's going to be 9 divided by 100, which is 0.09, divided by the number of compounding periods, and we've got compound interest being paid monthly, so that's going to be 12, which is actually equal to 0.0075, and then n is the total number of compounding periods. So we've got it being paid monthly, so that's 12. But then we've got that being paid monthly over 3.5 years, so that's 12 times 3.5, which is equal to 42 months. So we just basically put the number in the formula. FV is going to equal 20,000 times 1 plus 0.0075 raised to the power of 42. Which is equal to 27,372.99. Now we just have to be careful and make sure we answer the question. It's asking for interest, which is the future value, take the principal value. So that's going to equal 27,372.99 minus 20,000. And so our final answer is 7,372.99. So another example, what sum will become 9,826 in 18 months if the rate of interest is 2.5% per annum and the interest is compounded half yearly? So we know from this what sum will become. That means that's the starting sum. So that's actually looking for us to find the principal value. So we know that PV is equal to FV divided by 1 plus I to the power of n. And that we know that n is equal to the time in years times by the number of times it compounds in that year. So this is compounding in a year. So n in this case is equal to time is 1.5 or 3.2 years times by the number of times we compound. Well, we compound twice a year because it's half yearly, so that's just going to equal 3. We know I is equal to R over N, so our rate is 2.5, which is 2.5%, and that equals 0.025. And then we're going to divide that by, again, the number of times it compounds, which is twice. So it's going to be 0.0125. And so that gives us all the information we need. We've been told it's going to become 9826, so that means our future value is 9826. So principal value is going to equal 9826 divided by 1 plus 0.0125 raised to the power of 3. And so that's going to therefore, once you put that in your calculator and solve, it equals 9,466.55.